Welcome everyone, this is Dr. Mercola, and today we are honored to have Dr. Gerald Pollack, who is clearly one of the leading premier research scientists in the world when it comes to understanding the physics of water. So much so that in fact he even founded and is editor-in-chief of a whole scientific journal on that called Water. He's published a large number of peer-reviewed scientific journal publications and has also received even prestigious awards from the National Institutes of Health. So he is a well-respected researcher, and we are just delighted to have him today. So welcome, and thank you for joining us today, Dr. Pollack.
I'm very happy to be with you. Thank you very much. I would like to talk about water. I'm now editor of the research journal called Water, and I'm also a professor at the University of Washington in the Department of Bioengineering. And I've been studying water for quite some time. You know, most of us know the importance of water. In most cases, our grandparents or grandmothers always told us that when we're sick, just drink more water and you'll get better. In fact, there really is a basis to that. I know that water is absolutely central to people's health. I think what most people don't realize, we all know that the body is 2/3 water, but in fact, the water molecule is so small that 2/3 actually translates to 99% of the molecules of your body are water. 99%. It's amazing how much water there is. And in most medical students and other students, biology learn that water is kind of just not so important, just the background carrier of the more important molecules of life. But many years ago, it was shown 50, 60, 70 years ago, even by the father of modern biochemistry, Albert St. Georgi. It was shown that water is absolutely central to everything the body does, everything the cell does. And I was so moved and so convinced by that I wrote a book about 12 years ago called Cells, Gels, and the Engines of Life, which actually became quite a bestseller. And what that book did was to demonstrate that water is absolutely central to every fundamental function of the cell, whether it's muscles that are contracting or cells that are dividing or nerves that are conducting or whatever. And it turns out that these cells, as you know, they're filled with water, but the kind of water that fills the cells is not really the kind of water that we just ordinarily drink. Most people think that water is very boring and simple H2O. Well, what we found, and other people found earlier, that the water is actually molecules that are organized in some regular fashion. And so the water in your cells is not like the water in a glass of water. It's highly organized around the molecules that are inside your cell. So that's the kind of water we're talking about. What we did in experiments at the University of Washington is we examined that water in some detail, and this was the discovery. I think it's an important discovery, and we found out much more about the nature of this kind of ordered water. It's not so simple. Actually, it's not even H2O. I'll tell you in a moment about that. It's actually H3O2. So we found that what happens is if you have a charged or so-called hydrophilic or water-loving surface that's very similar to the surfaces of most of the molecules inside your cell. So what happens is that the water molecules transform themselves. The water molecules that are next to those surfaces, they're no longer H2O. They actually organize themselves into another structure. And what we found is that this structure's physical and chemical properties are totally and completely different from ordinary H2O. There are a few really important features. One is that this kind of structure is a bit like ice. It's a kind of crystal, and it excludes solutes. It excludes all junk and what have you. It's also charged. The charge is negative, and the water that lies beyond it is positive. So basically, it's like a battery. So next to all surfaces that are hydrophilic, including your proteins, you have this kind of special water. We call it EZ water, and we call it exclusion zone, but it doesn't matter. It's water that's structured or organized. It's negatively charged, and the region beyond is positive, and that constitutes a battery. And a battery means energy. So your cells, the water inside your cells, the water contains energy, potential energy. See, and that energy can be used. The other important feature of this that we found is that the energy needed to build up this cellular energy in water comes from light, the light that you absorb. And by light, I mean not only visible light, but also infrared light especially. It comes and builds this kind of water and basically builds the battery. So the bottom line is that this stuff is really important for your health. And so I wrote a book. The book was just released not very long ago. It's called The Fourth Phase of Water, Beyond Solid, Liquid, and Vapor. It really is another phase of water. We're all taught in school that water has three phases: a solid, and a liquid, and a vapor. And this is the fourth phase. So it's not three phases, it's actually four phases. And this phase is what exists. It's the prime constituent of the water that's inside your cells. So now, what happens if you're sick? That's an issue. So you can imagine, for example, if your kidney is not functioning, or your nerves are not functioning, your brain is not working too well, that means that the proteins inside those particular cells are not working as effectively, because the proteins are basically, they do the job, whatever the job is. But the proteins don't exist in the vacuum. Each protein is surrounded by this kind of EZ water that we're talking about. So it means if you have a pathology, it means that it's the protein and the water that are impacted. So one issue is, well, okay, so how do you get better? Now, I'm a physician. I can't tell you what physicians would prescribe, but I can tell you that getting those cells, as a cell biologist and chemist and physicist, whatever, engineer, that you need to get those cells back into shape. And one way to get those cells back into shape is to restore their pristine condition. Now, you can't easily supply the protein. You can do it perhaps by eating the right food, manufacturing the new protein, the protein that's functioning properly. But all those newly manufactured proteins need this kind of EZ water. So you have to supply this EZ water to get the cell back into its pristine shape. That's the important part. And, you know, it stands to reason. There are some very common remedies that we all know about. Again, grandma's remedies. So, you know, okay, one example is you sit in a sauna, right? And most people who do that, they feel pretty good afterward. They come out revived and energized. I think one of the reasons is that the heat from the sauna is actually infrared energy, and infrared builds EZ water. So when you sit in the sauna, basically what happens is you build up your EZ water, and especially in the cells where the EZ water is deficient, you build it up again. So if you're tired and your muscles ache and your brain is not functioning properly, you go in for 30 minutes and come out and you feel better. I think the reason you feel better is that this infrared energy builds up your resource, builds up the water inside your cells. And now the cells are functioning perfectly instead of functioning subnormally. So I think, you know, that's one of the ways that you can do it. There another way that has become popular, so-called earthing or grounding. You connect yourself to the earth, right? So why would that help? Well, it helps because, remember, this water is negatively charged, and the surface of the earth, you may not be aware of this. I became aware only 5 or 6 years ago that the surface of the earth is actually full of negative charge. The earth is negatively charged. This is not widely known now. It was widely known 50 or 60 years ago. My Russian friend told me that he couldn't believe when he told me that I didn't know about it. He said, When I went to school in Russia, every middle school student knew that the Earth was negatively charged. So how come I didn't know about it? But anyway, it is true. So you have the Earth that's negatively charged, and all of us know we feel good when we walk on the beach in our bare feet. It's something about it feels good. We don't. It's kind of ineffable, but somehow we feel better. And I think the reason we feel better is that all of those negative charges on the surface of the Earth infuse into our body if we're barefoot. And you can do the same thing by connecting yourself, as in fact my son does quite often too, plugs himself into ground, and by golly, he feels better. It's just almost the same as walking on the beach. And the reason, I think, is your cells are getting negative charge. They need that charge to build the negatively charged EZ water. So that's another way that seems to be understood in terms of understanding the water that's inside your cells. So one question is, what kind of water might be good to drink? This is not a simple issue or a simple question. Many people. Well, let me start. One idea is spring water, and most people know that spring water. Again, that you feel good when you drink spring water coming from a deep spring. And a question is, well, why is that the case? Also, glacial melt. I'll come back to that in a moment. But spring water is very deep, and water that's deep is under a lot of pressure. So pressure is the key. We found in our experiments that when you apply pressure to ordinary water, bulk water, we say H2O, when you apply pressure, that water turns into EZ water. Now, why does it do that? EZ water is more dense than H2O. And if you put pressure on water, of course, it will undergo transition to that more dense state. So just applying pressure gives you EZ water, and that's what happens in these springs that are under pressure. So if you drink the spring water, it contains a lot of EZ water, and drinking EZ water will help restore the EZ water that's in your cells. So it's a very simple idea, and I think it makes sense in terms of this kind of water being good for your health. And many people know that. People drinking spring water, it seems that in some cultures they live for many years. They live longer than most of us. And then there's also glacial melt. So we found in our experiments that ice is interesting. Now, most of us think that you take water and you put the water in the freezer and you get ice. And of course, that's true. However, in our experiments, we found that you can't go directly from ordinary water to ice. You go from water to EZ water to ice. That's a necessary transition from water to ice. And we found the same if you melt ice. It's the reverse. So you start with ice. The ice turns into EZ water, and the EZ water then turns into ordinary water. So what happens is that when ice is melting from the tops of mountains and you look at the water, it's a glacial melt. That water is very rich in EZ water. In fact, if you look at the glacial runoff, often the rivers or streams that come from the glacial runoff, they look sort of bluish green. There's a kind of green tint. And eventually, as they run down, they become this dark blue or black. This green is actually fluorescence that comes, the light is illuminating from up above, and the water, having a lot of EZ component in it, fluoresces. We found that EZ water fluoresces, and so I think that's what's going on. So if you drink either the glacial runoff or deep spring water, my guess, the evidence is not so clear, but I think that kind of water probably is good for your health and should promote longevity. We'd love to be able to test this, but it's not so easy to get support from the government to test the health effects of various waters, because the response is usually, well, water is so simple, everybody knows about water, how could water be good for your health? But I think it's absolutely essential, and we'd love to get support to carry out these really important studies of which kinds of water are good for your health. Now, besides these waters, there are others that people have produced, and because I organize meetings annually. It's called the conferences on the physics, chemistry, and biology of water. And many people come from all over the world. And people come who produce various kinds of water. And they come to me and they tell me about usually these waters are produced by putting in certain kinds of energy into the water. In some cases, minerals as well. And they tell me the unbelievable health effects of some of these. And, naturally, it's hard to judge. Some of these people are interested in selling their product and such. I've heard, however, from so many of these people, and I've heard from several of them who presented evidence to me of their curative powers, that I'm impressed that there is probably something to this. It can't be only selling this for the buck. We need to test it. It's really important to do that, to test short-term and long-term health effects. But I suspect that there really is something there, and this could be critically important for all of human health. Imagine just taking water, the simplest substance, giving it some energy or putting a few minerals in, and the fact that this could have important health effects and possibly curative effects. I've seen some evidence of that. It's very important to check this out. One question is, what water do I drink? And, well, it's a bit awkward. Many of these people who have come to me with different kinds of water suggest that, well, why don't we give you a sample, and why don't you go ahead and drink some of this water and see how you feel? And I discussed this with my wife, and it's very awkward for me to drink one kind of water, because people ask the question, and then others may think, well, that must be the best one because this guy seems to know what he's talking about, and therefore if he drinks this stuff. So the answer is, after a bit of discussion, we finally came to the conclusion that instead of avoiding all of them, why not drink every one of them? And so we're rotating from one to another. I do think there's something to this. And by the way, while we're at it, I just want to say something about juicing, because we've just come into contact with various people who do that. And at first I thought, well, this is another one of these diet fads but I've come to realize that juicing may be pretty much the same as drinking some of this water that is good for your health, because by juicing, so what you're doing is you're taking various vegetables and crunching them down so that only the juice remains. But this juice is actually the water that comes from the plant cells, and it's just full of easy water. So I think what you're doing by juicing is simply drinking easy water. And my guess is that should be good for your health. And I know many alternative medicine folks do that as a regular regimen. Seems to me that there's a really good rationale why this actually does work. It's good for your health. So we're drinking it. I'd like to mention also about antioxidants. We all know that antioxidants are good for your health, but nobody really understands the mechanism. It seems awfully complicated. And I just want to talk a couple of minutes about that, because, again, I think this relates to the water. And let me just back up a step. We're mostly cells. 60% of our bodies are cells. The cells are filled with easy water, and therefore our cells are negative. Much of the tissue that's outside our body, connective tissue, proteins, elastin, and collagen, also have easy water, and they're also negative. I'm getting at most of the tissues in our body are negatively charged. The exceptions you might think of are urine, feces, and perspiration too, stuff that we get rid of. Even when you exhale, you get rid of CO2, carbon dioxide, or carbonic acid. You get rid of protons, so all of this is getting rid of positive charge. So we're full of negative charge, and we try to get rid of positive charge, which means actually that we're negatively charged. If you add up, it's a simple arithmetic, add up everything that's in your body, you get net negative charge. That's not widely sort of conceived or accepted, but I think it might actually be true. Chemists like to think that everything is neutral. But it's not. I mentioned to you earlier about the negative charge of the Earth, and there are other examples where things are negatively charged. You can sometimes touch a kind of water and get a shock from it, and water stored for quite a long time. So charges do exist. I think you and I are actually negatively charged. Now, what's an oxidant? An oxidant is something that gives positive charge. It detracts from the negative charge. Now, if nature wants to keep us negatively charged, an oxidant robs us of this negative charge. That's not good. We become less healthy. And so I think what the antioxidants do is basically to help maintain that negative charge in our bodies, the same as earthing. And I think that's the reason why antioxidants actually work as they do. They just maintain the negativity and the easy water in our body, which is critical for every function that occurs in our body. What about sunlight? You know, if light is important, well, what about sunlight? And I think sunlight is critically important to our health. As I mentioned, the light is what drives the buildup of easy water. And a colleague of mine from New Zealand who suffers high blood pressure just lies in the sun during the day, measures his pressure periodically, very often, and finds that his blood pressure can plunge when he's in the sun. It always goes down consistently in the sun, and then it goes back up again. So that's his therapy, it's just sunlight. It makes sense. The sunlight builds the easy water, and it improves your health. And most of us walk out in the sun, and we feel really good, especially where I live in Seattle. It's kind of gloomy often in the winter. We get a lot of overcast, a lot of clouds. And when the sun appears, everybody feels good. And most of us think, well, it's purely psychological. It might be, but I think there's a physical aspect to it. That light is really doing something. Even our circulation, we think that our circulation is fully and completely driven by our heart. And of course, the heart is obviously critical for circulation. It builds pressure and it drives the blood around. But that might not be the only driver. If you get down to the very small blood vessels, the capillaries. So capillaries are really small, and your capillaries are probably 3 or 4 micrometers in diameter, really small. And the red blood cells that have to pass through those narrow tubes are actually bigger in diameter than the conduits. It's like having a pipe and trying to squeeze something through those pipes, something that's bigger. And people have shown that those red blood cells have to squirm through. They actually squeeze, they bend in order to get through. That's not so easy. You can imagine the energy required to force something big through a small pipe. It's sort of like, your toilet gets clogged and you have to get rid of it in some way. So those red blood cells have to work their way through. It wouldn't have occurred to me, or I think it wouldn't occur to anybody, but we have experiments in the lab that show that light is the driver of flow. So in the laboratory, we have a simple tube that we immerse in water, and it's like a straw, but it's made of one of these hydrophilic, water-loving materials. We just put this little segment of tube into water, and what happens is that the water flows through the tube, just like blood flows through your vessels. You don't have to put pressure on it. You just need light. And we found that if we can add light, this flow increases. You get a much higher velocity when you put in light. So if you extrapolate to what may happen in your capillaries, where it's really difficult for that blood to go through, and there seems to be no pressure difference across the capillary bed. So something is going on to help drive those red blood cells and help drive the blood through. We think it's light. And just recently, an Israeli group found that they were experimenting with, I think it was rats or mice, and they found that they stopped the heart, the animal died, and to their great surprise, the blood kept flowing for up to 1 hour after death. Now, this is unbelievable, but they report in their paper that this occurs for a period of an hour, and it occurred in all 10 experiments that they did. So it was not a fluke of some kind. Something is driving the blood, even when your heart is not driving the blood. And I think it might be light. And of course, we're going to try some experiments to check this and see if it's really true. If true, this would be a really interesting phenomenon in observation. But it's really hard to explain how after death you continue, the blood keeps flowing. And they mentioned something about turning on a laser and the velocity seems to increase. So we're just figuring out what might be going on. But I think light, sunlight, any kind of light, even infrared light that comes from the sun, or it comes from everywhere, you really can't get rid of the infrared light. If you, for example, turn off all the lights in your room, it's completely dark, and you turn on an infrared camera, you can get beautiful images of everything, no problem. And the reason is that you are generating infrared, the walls are generating infrared, the chairs are generating infrared, everything is generating infrared. And that's picked up by the infrared camera. So infrared is always there. It also comes from inside your body. And so it is possible that light from outside and light from inside, I call it light, but infrared is loosely part of light, that all of that is acting to drive processes inside your body, and one of which is blood flow in these tiny little vessels in the capillaries. So that could be pretty interesting. It's a new kind of concept about the energy that might be driving many functions inside your body. Another point, in Seattle, there's a woman who's become quite famous. She doesn't eat. Zero eating, and I think she's on her 35th day by now. She drinks, she doesn't eat. Of course, everybody is astonished. How could she live without eating? She seems to be doing quite well. I've not met her, but I read about her in the newspaper. In fact, other people have done that in the past. There are records, monks do it, and there's a book by a German chemist, and this guy drinks 2 glasses of juice per day, and he's been doing this for years. That's all. No food. Occasionally, he kind of craves food, and he'll take a few peanuts or something like that, but basically that's all. Almost no food. And the breatharians seem to do that. And the question is, how could you survive? The extreme case is a fellow from India who claimed 4 or 5 years ago that he hasn't eaten anything, or actually in his case even drunk anything, for 65 years. Now, of course, that's preposterous. However, I know the fellow who was head of the medical team who examined him for 2 weeks, sealed in the hospital room with people measuring everything they could measure over 2 weeks, and they absolutely certified that he didn't eat anything or even drink anything in his case. But of course, it's humid there, and so the question of hydration maybe is less of an issue. But other people, the question is, how is it possible that you can sometimes live just on water? And most of these people think they're living on light. The book by the German chemist is called Life from Light. And somehow he thinks he's getting his energy from light. Well, I think he may be right. The light comes in. The light provides energy to the water. It separates the charge. It builds structure. It builds easy water. And that easy water is absolutely central to every function in your life. So interesting tidbit, sidelight. I just want to say a couple of words about the new book that I wrote. The new book is actually the product of 5 or 6 years of work. And the book starts from the very basics of what we know about water. It brings in the results of a lot of experiments that we've done, very simple experiments that almost anybody could do on their kitchen table. That's how simple they are. Really simple, because for me, complicated experiments sometimes mislead. You know, you have an experiment with a big black box and you have some input and some output and you try to draw conclusions, but that big black box contains so many uncertainties that you're never really sure. So simple experiments. And from these simple experiments, we deduce the properties of water. We were able to figure out this 4th phase, which actually is not new. Many people, even 100 years ago, were suggesting that there might be a 4th phase. But from these simple experiments, we can figure out why this fourth phase, what's the nature of this fourth phase, and actually its properties are really simple. So from then on, the questions arise, well, so water has a fourth phase, and there's actually a lot of it, surprisingly large amount. So why is that interesting? Well, it's interesting because it applies to anything that water touches, which is almost everything, because water is all over. Water is in the sky, in the clouds, water is in the oceans, it's in the lakes and the rivers, and it fills the insides of our body. So the book touches on all of that in a very straightforward and sort of conversational way. It touches on that. In terms of health, the book doesn't really go into great detail about health, although it alludes to some of the kinds of things that I've been talking about the importance of water and cells. There are a couple of interesting things that I do bring up. For example, some examples are, well, swelling. Okay, so you have an accident, you break your ankle, and oddly, we all know that your ankle swells, but it swells so quickly. It swells. Perhaps some of you have had the experience. I've broken limbs quite a while and quite a number of times in athletics, and the swelling occurs within seconds, 2 or 3 seconds. Your joint may be almost twice the size as it was. That's really weird, because what's going on in cases like that? Well, most people think maybe some of the blood vessels are fractured or something in the blood, but that kind of oozing takes a really long time. Certainly it occurs, but I think the reason is that what happens is you tear some kind of tissue, and when you tear the tissue, the proteins tend to be exposed, and the water just loves those exposed proteins. It clings, and the water layers can build up to so many, millions of molecular layers is what we found in the laboratory, and so the water is almost literally attracted to those out that are fractured, and the swelling occurs almost instantly, just a matter of seconds. So that's one. Another area I discuss is, why don't your joints squeak? Okay, so in some cases our joints do squeak a little bit, but you can do deep knee bends, you can do push-ups, whatever, and there's not much friction in those joints. So the question is, well, how come? Now, think of two bones pressing on each other, say in your legs, right? And so you've got these two bones, and this bone will have cartilage on it, and the upper bone will also have cartilage, right? And the cartilage is basically nothing more than a gel. And we found that next to gels, we have easy water. So we have, these two bones and a gel, and then another gel, and in between them are two exclusion zones, two EZs, or this structured water. Beyond the EZs, remember I told you there's positive charge, there are protons. So this is the key. The key is that there's a layer of positive charges effectively between those bones. And positive charges repel each other. And so if they repel each other, that means that the bones are actually kept apart from each other. The people who make such measurements know that the bones or the cartilage never touches. They haven't a clue why they never touch. But I think the reason is the easy water produces the positive charges repel, and the bones are kept apart so that when they rub against each other or try to turn, there's no friction, or almost no friction, and that's why your joints don't squeak. Well, I'm not sure about yours, but I know about mine, and they don't really squeak. So that's another of the areas that's touched on in the book. If you would like to learn more about the book, the best way is to visit www.ebner&sons, EBNER and Sons, all one word, .com, and there you can freely read without purchasing. You can read 3 or 4 chapters and get the gist of what's going on, and I think that could be useful. Before I quit, I just want to say 1 or 2 words about the history of water. Most people think that everything there is to be known about water is known about water. After all, it's the simplest molecule we can imagine. And because of that, a lot of people have stayed away from water. And scientists have stayed away from water too, because there were a couple of debacles that took place, one in Russia and one in France, 20 years ago and 40 years ago. And people have found some really interesting properties of water. And these properties of water, one of them was some kind of organized or structured water, which actually I think is similar to what we found. The Russians found it first. And the other was that water may contain memory, like an imprint of the molecules that it was in contact with earlier. And a lot of scientists railed against those observations, thinking how preposterous those observations were. It's not so clear that they actually were, these people were wrong in what they found, but an image was created of an area of research, that is water, that's untouchable, because it's pretty risky to get into water research. And I think that has kept scientists away from penetrating deeply into the nature of the most common substance on the earth. So we've done it, and some other people are getting into it, and I hope more do. And the water is central to just everything we do and everything in our bodies. And I guess I'd like to close on that. Water is extremely important for everything we do. Thank you very much.